Hello dear students, today we are solving exercise 14.2 from the IGCSE book Mathematics Core and Extended by Morrison. You can see which book is this. We are gonna start with question number 1A, which is a set of simultaneous equations, and we have to solve this equation by using the substitution method. So the very first key of substitution method is to isolate one of the variables, and you can choose either of the equation first. I will first name them as equation 1 and equation 2. So I am choosing equation 2 because here actually the y is already isolated and I don't have to do some extra steps, and my y is the subject of this equation, which is y equals to x plus 3. So from this equation I will take the value of y and I will substitute the value of y, which is equals to x plus 3, in equation number 1. So in the next step I will tell you how I will do this substitution. So now I will substitute the value of y, which is the very first term of equation number 1. Instead of writing y, I will write x plus 3, and after that I will copy everything which is given in equation number 1, which is plus x equals to 7. So you can see now my equation is changed into one variable form. Now I have 2x and 2 numbers, and we all know how to solve these kind of equations. Now we are gonna add x with x and number with number. For this, what I'm gonna do, first my target is to remove all the numbers from the left side and take them to the right side. So here we can see that there is a plus 3. What we will do, we will choose the opposite of plus 3, which is minus 3. So I will do minus 3 on both of the sides. Okay, after this I am gonna cancel the plus 3 with minus 3, and on the left side I am only left with x plus x, and on the right side I have 7 minus 3. Now when I will add x plus x, I know this is 2x, and when I will solve the right side, which is 7 minus 3, I will be left with a 4. Now again I want to make this x all alone, so I can see 2 is being multiplied with the x, so I will do the opposite operation, which is dividing by 2. So I will divide my both sides with 2, and now I can cancel 2 1s are 2, 2 1s are 2, and on the other side 2 1s are 2, 2 2s are 4, and in this way I got my very first value, which is x equals to 2. Now we will do substitution for the second time. When you find out the first variable, you have to take that variable and choose the equation, any equation you can choose. I am choosing here equation number 2 because it is already simplified. It is showing me y equals to x plus 3. So I will take this y equals to x plus 3 and I will substitute the value of 2 in this equation. To do this, I will write y equals 2, and then in place of the x I will put 2, and other things will remain as it is. So you can see I put y equals 2 plus 3, and when you will add 2 plus 3, your answer is very simple, y equals 5, and that's it. You are done with the solution of very first question. X equals to 2 and y equals to 5 is the solution. Now if you want to double check that if the solution is correct or no, what you are gonna do is you take the value of x is equal to 2 and y equals to 5, and you can choose either of the equation and substitute these values again. Substitution means you are gonna put the value in place of x, you are gonna write 2, and in place of y you are gonna write 5, and you can check that if the both of the sides are equal or no. So here I have chosen one of the equations and I put y equals to 5, and in place of x I put a 2, and when I solved it, it gave me 5 equals 5, and yes, this is the correct solution. Now let's move on to question number 1b. Here again we are lucky that our equations are already solved in such a way that in both equations you can see that y is on one side and x and the number is on the other side. So I have named them equation 1 and equation 2, and I can choose either of the equation. Again I am choosing equation number 1 here because I need my y on the left side and my other things on the right side. So let's take the value of y, which is equals to 1 minus x, from equation 1 and substitute this value in the equation number 2. X minus 5 equals to, here there is y in equation 2, so I will not write y but I will write 1 minus x. So now my target is to put the x on the left side and to put the numbers on the other side. So first I shifted my x on this side, so it became x plus x minus 5 equals to 1 minus x plus x. I did plus x on both sides. Now I will do the cancellation, and after this I will do the same thing with the negative 5. I have to move negative 5 on the other side, so x plus x become 2x, and then I will remove this negative 5. So the opposite of negative 5 is positive 5, so I will do plus 5 on both sides, and it is 1 plus 5. Now I will cancel out the negative 5 and positive 5, and now I have 2x equals to 6. Again I will use the opposite operation, so divide by 2 on both sides, and here you can see after cancellation I got my value of x, which is x equals 3, and this is my first solution. Now to find out the value of y, again I will resubstitute this value of 3 in either of the equations, and the best is equation number 1, and y equals to 1 minus x. I will take it, and in place of x I will put 3, and you can see I got my second solution, which is 1 minus 3 equals to negative 2. Now let's solve question number 1c, which is 2x plus y equals to negative 14 is our equation 1. And here also we can say that we are lucky that equation number 2 is already a solution. We have to only solve half of the part. So here I will substitute the value of y equals to 6 in equation number 1. I will write 2x plus 6 equals to negative 14, and here you can see that we have two numbers and one variable. So 2x will remain as it is, and I have to move the number 6 on the other side, so I will do minus 6 on both sides. After that I will cancel the 2 6, and I will do minus 14 and minus 6. Negative makes addition, so I will do negative 20, and after that divided by 2 on both sides. Now I got my value of x equals to negative 10, and I already have the value of y, which is y equals to 6, and this is the solution of this equation.